All right, this is the fifth FRQ from the 2016 BC exam. So part A says to find the average value of the radius of the funnel. So anytime we do average value, that means I'm going to have 1 over b minus a, and then the integral. And so the function for radius is this function right here. And the interval for that is from 0 to 10. So I'm going to do b minus a. And we've got from 0 to 10, and we have of 1/20th times 3 plus h squared dh. Okay, so what I'll go ahead and do is just kind of pull both of these fractions out to the front as a coefficient. So I have 1/10 times 1/20th, which is 1/200th. And then I'm going to go ahead and integrate. So I have 3h plus 1/3 h cubed. So I have 3 times 10 plus 1/3 times 10 to the third. And then if I plug in 0, I get 0 plus 0. So I have 1/200th times 30 plus 1/3 of 10,000. Yeah, 10 to the third, 10,000. Okay, so 30 is actually 90 divided by 3. Okay, so I have 90 plus 1,000, which is 1,090. So I'm multiplying kind of like straight across the top. And then on the bottom, I have 200 times 3 is 600. Divide by 10 on the top and the bottom. So 109 over 60. And I'm just going to leave it there. I'm not going to simplify any more than that. And you could leave it up here. You should be able to leave it up there and be fine. Okay, part B. Find the volume of the funnel. So this is where I have to, this part of the problem is the most subtle. The setup is you have to remember back to what the formula for volume is. So volume is actually the area of the base multiplied by the height. In general, the area of a funnel, or the volume of a funnel is obviously going to be different because in this funnel the height is changing, the radius is changing. Well, the height isn't changing, but the radius is changing based on the height. And so we're going to say this is area of the base, pi r squared, times the height, which we'll call h. Okay, so if we're going to set this up as an integral, then we're going to say for volume we have the pi, right? And they have the integral from 0 to 10, and the integral is going to be based on the radius changing, and then the height. So I'm going to have r squared, so 1/20th, 3 plus h squared. There's r squared, and then dh is that height. So I've got pi r squared h. Interesting problem, right? But that's kind of how it works. And if you think about integrals, what we want to do if we want to find the volume of the entire funnel is we're thinking about, we're having like a little circle right here and a little circle right there and a little circle right there and a little circle right there and a circle right there and a circle right there, all these circles, right? And then we want to add them up, and we have infinitely many circles from 0 to 10. And so that's what we're doing is we're getting all of these circles, the pi r squared, and then we're adding them up from 0 to 10, which is kind of why this formula makes a little bit of sense, actually. Okay, so off to the side, I'm going to say we've got 1/20th, 3 plus h squared times 1/20th, 3 plus h squared. And the 1/20th I'll just pull to the front is 1/400th. And then I can FOIL this. So I've got 3 times 3 is 9. 3 times h squared plus h squared times 3. And then h squared times h squared. Okay, so I've got the pi in the front. I'm going to move the 1/400th to the front. And then I've got 9 plus 6h plus 6h squared plus h to the 4th dh. So that's the work that I'm doing by hand. Okay, so I've got pi over 400. I've got 9h plus 2h to the 3rd plus 1/5 h to the 5th, and I'm evaluating that from 0 to 10. Okay. So this is what I get when I plug 10 in for everything. And then when I plug 0 in for everything, I just get 0. So I'm subtracting 0 off the end. All right, so I've got pi over 400. 9 times 10 is 90. 2 times 10 to the 3rd. 10 to the 3rd is 1,000, so 2 times that would be 2,000. 10 to the 5th is 100,000, and we have 1/5 of that, so that's being divided by 5. All right, so if I do 100,000 divided by 5, if I just think of 100 divided by 5, that's 20. So that's actually 20,000. So I have 20,000 plus 2,000, that makes 22,000, plus 90. And I'm multiplying that by pi over 400. And then I can go ahead and divide by 10, divide by 10. And I'm going to go ahead and leave the answer like this. All right, part C. So it says we have liquid that's draining out of the bottom. At the instant when the height of the liquid is 3 inches, the radius of the surface of the liquid is decreasing. So if you were reading this, you should be thinking, oh, that's a related rates problem. We have the rate of something is changing in relation to time. So I'm going to start off just writing out my equation for R. So that was 1/20th times 3 plus h squared. So I've got R is 3/20ths plus 1/20th h squared. And then I'm going to think about all the information I have. So they told me that the height was 3. They've told me that dr dt, the rate that the radius is changing, is -1/5 because that radius is decreasing. And then they've told me that the rate of change of the height is what I want to find. So I'm going to go ahead and take the derivative of this. So the derivative of R is dr dt. The derivative of 3 over 20 is 0. I don't need to write the plus. The derivative of 1/20th h squared would be 2/20ths h to the 1st times dh dt. So I've got -1/5 equals 1/5 times 3 times dh dt. Sorry, 2 over 20. 2 multiplied by 1/20th is 2 over 20. Sorry. Okay, 1/10. All right, so I've got -1/5 equals 3/10 th dt. I hope you can hear the cat right now going nuts. To get rid of the 3/10, I'm going to multiply by 10/3 on each side. And then 10 divided by 5 is 2, so I've got -2/3. And if we look back at the units for the height are going to be the same as the units for the radius because they're both just lengths. And so the units for the radius was inch per second, and so for this we're going to have inch per second. So as the radius is decreasing by 1/5 inch per second, the height is decreasing by 2/3 inches per second.